Alright, so to graph an exponential function, we need to first understand a few basic things about an exponential function. So if we have, in this case, it looks like all these answers are 5 to the x, have 5 to the x. Let's say we have the function 5 to the x. Alright, let's pick some values of x. My favorite ones are 0, 1, and negative 1. 5 to the 0 is 1. Alright, anything to the 0, in fact, is 1. That always is true. Now if we do 5 to the 1, well, that's boring, that's just 5, right? 5 raised to the 1 power is 5. And 5 to the negative 1, remember a negative exponent means if you put it in the denominator, you get a positive. So negative exponents mean positive exponents in the denominator. So 1 over 5 to the 1 is 1/5. Alright, and this boils down to any base, no matter what it is, should always go through 0, 1, 1a, negative 1, 1 over a for any function a to the x. Right. So the base changes in a later question and it's 4. It's 0, 1, 1, 4, negative 1, 1 over 4. Right. So if we graph that, 0, 1 right here, 1, 5 is over here, and then negative 1, 1/5 is getting down here. Alright, so our graph, our f of 5 to the x graph should look like that. Alright, now another thing I want to point out here, let's just say for kicks here, what if I put in like a negative 1,000? Alright, that's 5 to the negative 1,000. That's 1 over 5 to the 1,000, and your calculator can't even do 5 to 1,000. It's such a huge number. This is huge. Alright, so 1 divided by a huge number, 1 divided by like a million, right, is approximately equal to 0. So the more and more negative our numbers get, the closer we're getting to this little dash line here, and it's trying to get to 0. It'll never get there because 1 over a million is a small number, but it's still something bigger than 0. We call that number there the asymptote. Alright, and it's usually at y equals 0. Alright, as this one is. Alright, so now what we have here obviously is not 5 to the x. We have this blue line. Alright, so let's talk about a couple other things. One is shift. Alright, so vertical shift happens when you take 5 to the x plus c. Alright, so if c is a positive number, that moves it up. If c is a negative number, it moves it down. Now, since our asymptote is still at y equals 0, we know that in our problem we have no vertical shift. Alright, if you see the asymptote going through y equals 2, you know you got moved up 2. Alright, now the other one is horizontal shift. Alright, that one happens when you have the plus c up here in the numerator. Alright, and in this case, a plus c actually moves you to the left, and a minus c actually moves you to the right. It's kind of counterintuitive to what you think. So do you see we have some horizontal shift going on because instead of going through 0, 1, we're going through 1, 1. So we've been shifted right 1. Alright, so that's why I mentioned this right here. If you don't go through 0, 1, you have some shift. Alright, if the asymptote moved, then you moved up. But if the asymptote didn't move from y equals 0, that means you shifted left and right. So we went to the right one. So that means we're going to have this right here, a minus c. Now the other thing that can happen is you can have a flip, and we have a flip. So y-axis flip happens when you change the base to a negative like that. So 5 to the negative x means a y-axis flip, and then x-axis flip occurs when you have negative 5 to the x. Well, in our case, we have, looks like it's y-axis flip. We're not down here somewhere. So we flipped about the y-axis. So we have this negative as well. Now this is where this algebra gets a little bit tricky. Alright, so we have a 5 to the x minus 1, right? That was this green shift that I indicated here. So this means move right 1. And now the second thing we have to do is we have to flip it about the y-axis. So y-axis flip occurs with a negative up here. So we put a negative there. So we have 5 to the negative parentheses x minus 1. And if you distribute that negative, you get 5 to the positive 1 minus x. And that's why it is g.